So let's just look at some, let's just do some exploration. So you see this Wikipedia now, the online dictionary. It says, online encyclopedia, hypothesis, singular plural ends with es, is a proposed explanation for a phenomenon. For a hypothesis to be a scientific hypothesis, the scientific method requires that one can test it. Okay? Scientists generally base scientific hypotheses on previous observation that cannot satisfactorily be explained with the available scientific theories. Okay, let's go back a little. Okay, let's look at this. In common use in the 21st century, hypothesis refers to a provisional idea whose merits requires evaluation. For proper evaluation, the framer of the hypothesis needs to define the specifics in operational terms. Okay. Yeah, I think I like this one. The hypothesis is a supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation. All right. In statistics. In statistics, the hypothesis is defined as a formal statement which gives the explanation about the relationship between the two or more variables of a specified population. Okay? It helps the researcher to translate the given problem to a clear explanation for the outcome of the study. All right, so did we make something out of all that?
So,
Okay. Can you see my screen? Can you see my Excel screen?
yes, sir. Yes,
Okay.
sir.
All right.
Yes.
Okay, so generally speaking, we know that hypothesis is, in very simple terms, an hypothesis is a claim which is meant to be subjected to a test in order to validate that claim. I'm trying to just put it in the straight, ordinary form. Okay, it's a claim or a proposition, which is yet to be tested to ascertain its validity. Okay, so usually when someone comes up with a hypothesis, when someone or a group, body or whatever comes up with a hypothesis, the hypothesis needs to be proven, because usually hypotheses challenge something that already exists. Hypotheses usually challenge existing ideas or existing beliefs about a particular subject or about a particular situation or a particular thing. Okay? For example, someone just comes up and says, a doctor just comes up or a scientist and says, oh, finally he has found the cure to HIV. Now, that is the doctor's or the scientist's claim. It's a proposition, but not until it is tested. Everybody will not accept that. Are you following? So the guy can't just come up and then produce some drugs and tell us it can cure HIV, then hospitals just start accepting it and dispensing it, administering it to patients. It's not possible. Okay.
There will be further investigation.
Yes, it has to be investigated. That claim has to be subjected to investigation, to ascertain its veracity. Okay. So that's that. So usually when formulating hypothesis, we formulate um, usually a dual hypothesis, the null hypothesis and the alternative hypothesis. The null hypothesis is usually formulated to specify the status quo, what is currently believed to be true. That's usually the null hypothesis. The alternative hypothesis is usually the one that challenges that, the opposite to that. Okay. So in the case of HIV, the null HIV drug, the example I just gave, the null hypothesis would state that the drug cannot cure HIV. Why? Because at the moment, it is believed that HIV does not have a cure. I don't know if the cure has been discovered now. But as far as I know, HIV does not have, the world believes that there's no cure for HIV. So the alternative hypothesis state that the drug cannot cure HIV. Sorry, that's the null hypothesis. The alternative hypothesis will state that the drug can cure HIV. Is it clear?
It's clear, sir.
Clear. Okay.
So
So
about I cannot see your screen. It just booting something. It's just rolling.
you can't see my screen.
The one I'm seeing is just booting, like something is rolling.
Okay. Just a minute. Let me see. Okay, so in hypothesis testing, the first thing you want to do is formulate the hypothesis. Okay, let's take an example. For example, you are required, let's say this sample data is taken from students, those students of an international school. Okay, and let's say they are predominantly Nigerian students and British students. Okay, and for some reason it's required that you help investigate to see if there's a difference, statistically significant difference between the performance of the Nigerian students and that of the British students in mathematics. Okay, and then you have this sample data to work with. Right? Now, You want to see if there's a difference between the mean performance of Nigerian students and the mean performance of the British students. Now, this is a test of mean. It's a test of mean, right? Now, for this kind of problem, the first thing, of course, like I said, the first thing you want to do is formulate the hypothesis. The hypothesis will state that the null hypothesis, which is HO, will state that what? Will state that there is no difference between the performance of the Nigerian student and the British student. So if Nigerian student is X1 and British student X2, then we can say HO states that X1 equals X2, or average of mean of the scores of Nigerian students is equal to the mean score of British students. Then H1 or HA, which is alternative hypothesis, will state that they are not equal, right? They will state that they are not equal. So this is the hypothesis for this problem. That's the hypothesis for this problem. Now, the next thing, you want to set the significance level. Okay, the popular value for significance level is what? 5%, right? 5%. That's the popular value for level of significance, which is the same thing as 95% confidence level, right? Actually, generally, that would mean that a 5% error is permissible. Okay? I think that's an easy way I can explain that. Yeah. So now this kind of problem can be solved using t-tests. Why? Because this is a test of mean, and we are dealing with just two samples, two small samples. It's a test of mean, right? Now, t-test is a statistical test that is used to compare the mean of samples, the mean of two samples. There are three types of t-tests you can carry out. You can do a one sample t-test, paired sample t-test, or independent sample t-test. One sample t-test is when you are comparing the mean of a sample with an already established mean. Okay? For example, let's say you want to test if the mean score of students, maybe Nigerian students, is, let's say you want to test if the mean score of students, let's say you want to test if the mean score of the students is greater than 50%. Okay? Greater than 50%. So here you see that you are comparing the mean of a sample with a figure, and not already calculated figure. This is a one sample t-test because you are dealing with one sample, the X sample or whatever. Okay, this is a one sample t-test. Now, when you're talking about independent sample t-test, This is an example of independent sample t-test. For here, you are dealing with two samples which are not related, okay? They are not related in the sense that these samples pertain to entirely different individuals from this sample. So this is an independent sample t-test. Okay. What then is dependent sample t-test? If, for instance, these samples pertain to the same individuals, let's say pertains to the same individuals, okay? For example, if these are scores, the scores in a first term, and these are scores in term 2, and you are dealing with the same individuals. Let's say, for example, you have the registration number, 1001, 1002, so forth. Okay, you can see that this pertains to one person, right? That's another person. So you see that these samples and this sample pertains to the same individuals. Is that right?
Yes, sir. Sir.
This is a paired sample t-test. These are paired samples. These are paired samples. So you should know the difference between paired sample and independent samples.
Sir, is it paired or dependent?
But yeah, you can call it dependent or paired.
Okay.
So this is independent samples. Okay. Sometimes they simply call this two sample t-test. Two sample t-test or independent sample t-test. This one is called paired t-test. Paired t-test or dependent sample t-test. Okay, so that's that for the type of t-tests. So you see two sample, dependent sample. Right.
So, sir, you mentioned that when you are carrying out samples or observation that involves just fewer, um, fewer data, you use t-test. But if it's a larger sample, what test are we going to use?
If you have two samples like this and it's a test of mean, you can use t-test. Or if you have multiple samples, maybe more than two samples, okay, more than two samples, which usually is independent samples, then you can use ANOVA. Can do ANOVA test. Usually, when you are dealing with more than two samples, you resort to ANOVA test. Exactly.
Yes, sir.
Okay. So that's ANOVA test. Okay, so that is that for the introduction. So something you should observe here is, if you look here, this is the average of the Nigerian student score. This is the average of the British student scores. Are they the same?
No, they are different
They are different.
values.
So why are we trying to test if they are different or they are the same? Now, the actual means are different, but we need to test if the difference is statistically significant. Okay? We need to test that. So that's what we are about to do. So we'll test, we'll look at that. Okay? Let's see how it goes.